Okay, moving on to section 10.6. If you remember in section 10.5, we were multiplying radicals, right? Square roots, cube roots, and so on. So now we're going to be doing division of radicals. And, well, on the one hand, we have this rule over here, right, which says that you can take the nth root of a divided by the nth root of b and form a single nth root of a divided by b. Okay, so yeah, that's our guiding principle here. This is what we're going to use to divide square roots or cube roots or fourth roots or any nth roots. Right? However, if you remember a couple of videos ago, I think in section 10.3, yeah, it was way back in 10.3, we had these three rules about when a radical is considered simplified, right? So we want to simplify our radicals. And the one we did in 10.3, we specifically focused on the first rule, that all factors have powers that are less than the index, right? In other words, if you have, let's say, a cube, let me try that again. If you have a cube root, right, you can have x to the power 1. You can have x to the power 2, but what you cannot have is x to the power 3, because we can simplify that as x, right? Likewise, you cannot have the cube root of x to the 4, because 4 is not less than 3, and you would simplify that as x times the cube root of x. So we did that back in 10.3. Right? So yeah, that's the first rule. But now we're going to concentrate on these two rules, which up until now we've basically been ignoring. But now we have to look at these more carefully, because we are going to be dividing, and so we might get, say, fractions, right? So what happens when we have, say, the square root of a fraction, right? So this rule 2 here, rule 2, says that any radicand cannot contain a fraction. What's under the square root cannot be a fraction, right? So I cannot have the square root of 2/3, right? This is not simplified. Okay? So you cannot have a fraction underneath the square root or cube root and so on, right? So that's what rule 2 says, right? Rule 3 says you can't have radicals in the denominators, right? So if you decide to split this up and write it as the square root of 2 divided by the square root of 3, and you are allowed to do that, right, by this rule way up here on the right, top right. See that? So, right, that rule says you can split them up. However, rule 3 says you cannot have a radical, a square root, in the denominator, right? So this is also not simplified. So that's right. So that seems like we can't win. No matter what we do, we're not going to be able to simplify things like these, right? So let's make that our first example, right? Let's divide and simplify. Actually, yeah, I mean, simplify, divide, divide, simplify. The directions in the book are also going to say the following. We want to rationalize the denominator. Okay. And once we do that, rule 2 and rule 3 will be satisfied. Denominator. Okay, so rationalize the denominator. Okay, so yeah, let's look at the square root of 2 divided by the square root of 3. So in other words, this right here, right? Well, what could we do here, right? We could combine them using this on the very top right here, right? So once again, we're going to use this rule and write this as, pardon me, as the square root of 2/3. So we're allowed to do that. However, we've gone from violating rule 3 to rule 2 now, because this has a fraction in it. And remember, the radicand cannot contain a fraction. Well, it can, but it's not considered simplified, right? If it is. So yeah, because of that, this actually turns out not to be helpful. So we don't want to do that. Okay. So what can we do? So let me scroll down a little bit, and let's write what we have here. The square. Yeah, I'll do it down here, right? Square root of. Yeah, let me use green here. Square root of 2 divided by square root of 3, right? We want to rationalize the denominator. Right, so here's how that's going to go, right? We have our square root of 2 divided by square root of 3. And remember, the problem is we can't have a square root in the denominator, right? It's not allowed, right? It's not considered simplified. But here's what we can do. We can multiply the denominator by another square root of 3, right? Now, remember, if you do that, you better multiply the numerator by the same thing, right? You are allowed to multiply by 1, right? In other words, we could cancel these and we're back to the beginning. But here we don't want to cancel them. Right? So what we want to do in this case is think of what's the denominator here. The square root of 3 times the square root of 3 is the square root of 3 times 3. It's the square root of 9. And what's the square root of 9? Well, it's just 3. So that got rid of the square root in the denominator. By multiplying by itself like this, you're essentially squaring the square root, right? You're taking the square root of 3 times the square root of 3, which is the square root of 3 squared, which is just 3, right? Because the exponent and the index match. All right, what about the numerator? The numerator is the square root of 2 times 3, but 2 times 3 is 6, so the numerator is the square root of 6. And we're done. This is the answer. This is what we're looking for, right? So let me just rewrite this up here. We have the square root of 2 divided by the square root of 3. That was the original question. And the answer, what we got, is the square root of 6 divided by the square root of 3. And, you might think, well, these don't look anything alike. They look like they're two different numbers. And so you should maybe convince yourself that these are actually equal. And the best way to do that is use your calculator. Calculate this thing here on the left, and then do the same thing with this thing here on the right. And what you'll find is you get the same decimal for both of these, right? And so it turns out these are equal, right? Now, the other question is, well, why do we prefer this over this? Well, remember, way back up here, Rule 3 says you cannot have a square root, a radical, in the denominator. So this square root of 3 here is a radical. It's a square root, and it's in the denominator. Well, that's not allowed. On the other hand, over here, this 3 does not contain a square root. There's no square root in the denominator. Okay, so for that reason, this is considered simplified, whereas this is not simplified. All right. So essentially that's what we mean by rationalize the denominator. We're taking an irrational number and turning it into a rational number. Okay, so the word rationalize in math means, get rid of the square roots or get rid of the irrational numbers. Right. We're not trying to make sense of the denominator. It's a different definition of rationalize. Anyway, so that's our first example, and let's do another one just to make sure you have the right idea. Okay, so the next example, rationalize the denominator. We have the square root of 3x divided by the square root of 8. Okay, so again, what's the problem here? Let me write it over here. We have the square root of 3x divided by the square root of 8. And remember, you cannot have a square root in the denominator. So that's the issue here. And so how do we get rid of that square root in the denominator? Well, we can do the same trick that we did in the previous problem, right? We can multiply numerator and denominator by just the same denominator, the square root of 8. Right? So you're always allowed to do that because you're just multiplying by 1 here. Right. Now, what does that get us? Well, notice the denominator is really the square root of 8 times 8, which is the square root of 64. So no problem there. And then the numerator will be the square root of, 8 times 3 is 24. And then don't forget we still have this x inside. So we're okay with that. And the square root of 64 is just 8, right? So we got rid of the square root in the denominator. And the numerator is just the square root of 24x. Right? And you might think we're done. After all, we got rid of the square root in the denominator. We're not violating rule 3 here. One thing I should mention, of course, there's no problem with having a square root in the numerator. That's perfectly fine. The only issue is the square root in the denominator, right? That's not allowed. But you can certainly have a square root in the numerator. And if we go back to the first example, yes, of course, we had square root of 6 in the numerator. And the square root of 6 is irrational, right? And there's no way to simplify it. But we're allowed to have a square root in the numerator, right? Just not in the denominator. Right. So that's not the issue. There is one other issue here, though, and it goes back to the first rule. You can't have factors that are powers less than the index. Okay, so let me, so yeah, in other words, we're not done here yet. So let me go down here and see what the problem is. So let me break this apart. We have the square root of 24 times the square root of x over 8. So the issue is the square root of 24, right? And the reason is because 24, if I go way up here now, right, 24 contains a perfect square, right? Originally it was 8 times 3, but 8 and 3 are not perfect squares, right? Remember, this is not the cube root of 8, right? It's the square root of 8. Right. So you can do 2 times 12, or you can do 3 times 8, but what we should do is 4 times 6, right? 4 is the perfect square, right? The square root of 4 is 2. And 6 is, well, 2 times 3, but there's no perfect squares here. So we'll leave this as 4 times 6. All right. So, yes, so that means the square root of 24 you can write as the square root of 4 times the square root of 6. And the square root of 4 is 2. And the square root of 6, we leave that alone. After all, we left that alone up here too, right? You're allowed to have square root of 6 in the numerator. So the square root of 24, right, here it is again, square root of 24 is 2 square root of 6 times square root of x all over 8. All right. Now there's 2 more things we can do here, right? 2 over 8, we know that reduces to lowest terms is 1 over 4, so you're essentially canceling the 2's. And the other thing is you can combine these under a single square root, right? So the numerator is just going to be 1 times the square root of 6x. And the denominator will be 4 because, 2 over 8 reduces to 1 over 4, right? Okay. So I hope that helps, and this should be our final answer, right? Let me circle that again here. Right. This is our final answer. Right. So again, what happens if you leave it like this? You're going to lose points for not simplifying the numerator. The 24 contains a perfect square, right? Meaning, right, the square root of 4 here, right? That's a perfect square. And if you remember, right, rule 1, the factors cannot have powers less than the index. And so here, the square root of 4 is really the square root of 2 squared. So 2 is not less than 2. So in other words, leaving it as the square root of 24 violates the first condition, the first rule, way back up here. Okay. All right, well, let's do one more. Just make sure that this makes sense. Okay. 10 divided by the square root of 5. Right. 10 over the square root of 5. We want to simplify that. Or, rationalize the denominator. Same thing. Denominator. Right, so how do we do that? Well, just rewrite it first. And then recognize that, again, the square root of 5, there's no way to simplify that. So we're simply going to have to multiply by the square root of 5. Right? And then do the same thing on the top. And that gets us in the denominator, the square root of 5 times 5 is 25. In the numerator, we can just leave it as 10 times the square root of 5. And now the square root of 25 you should recognize as 5. And finally, 10 divided by 5, right? 10 divided by 5 is just 2. So this is really 2 times the square root of 5, right? Oh, over 1 if you like, but we don't need to write that. It's like 5 divided by 1 is 5, right? So 2 square root of 5 divided by 1 is just 2 square root of 5. And that's it. So I hope this helps. Maybe one more thing. Now that I think of it, I'm suspecting that some of you might be thinking, how is this completely simplified? Let's go back to the first example here. The square root of 6 divided by 3. So some of you might be thinking, well, wait a minute, isn't 6 divided by 3 2? And so why isn't this just the square root of 2? Right? So that's a good question. But I wish I thought of it earlier, but better late than never, right? So yeah, why can't we simplify this, right? And the answer is because you're comparing apples and oranges here. The numerator has a square root. The denominator does not, right? This is not the square root of 3 down here, right? So yeah, you have apples and oranges. You cannot combine these, right? Okay, so yeah, don't do that. Just to clarify, though, that if I had something like this, suppose I have the square root of 6 divided by the square root of 3. Well, now, by this rule up here, you are allowed, because you're dividing, right? You're not adding or subtracting, you're dividing. You are allowed to write this as a single square root. So you can write this as the square root of 6 divided by 3. And now, 6 divided by 3, of course, is 2. So this is the square root of 2. Right? So yeah, the square root of 6 divided by the square root of 3 is really just the square root of 2. But now notice the difference with this problem here, the one in green right here, right? There is no square root of 3 in the denominator, so you can't combine the 6 and the 3. One has a square root, one doesn't. And that's why you cannot simplify this any further. This does not become square root of 2. You simply have to leave it as the square root of 6 divided by 3. And so that's why that's simplified there, right? So I hope that helps, right? And yeah, so let's go on to a slightly harder problem now. Okay, so example 4, we want to simplify or rationalize the denominator, 6 divided by the cube root of 4. Yeah, so I don't think you're going to see a whole lot of cube roots either in the homework and certainly not on the tests. But, you know, maybe there will be one, right? So just in case, let's do one with the cube root, but we won't spend too much time on it. So yeah, so let's rewrite this. It's still 6 divided by the cube root of 4. And you might be thinking, well, then do the same trick here, right? Multiply top and bottom by the cube root of 4. Unfortunately, that doesn't work here, right? That only works because when you have a square root, that works. This does not work here, okay? Okay, so why not? Why not? So what happens if we do this? What happens is the following. The numerator is fine. The numerator is 6 times the cube root of 4, and so there's nothing wrong with that. The problem is the denominator, right? Remember, 4 times 4 is 16, and you get the cube root of 16, right? So this would have worked if it was the square root. The square root of 16 is 4, right? But the cube root of 16 is not 4. In fact, I think we did this one in one of the previous videos. So I'll remind you, the cube root of 16 is the cube root of 8 times the cube root of 2, which is 2 times the cube root of 2. Right? So even when you simplify this, you're still going to have a cube root in the denominator. You don't get rid of the cube root here. Okay? So yeah, multiplying by just the cube root of 4 is not going to work, right? So all right, so then what does work? What should we be doing here instead? So remember, we want not a perfect square, but a perfect cube. So what's the next biggest perfect cube? Remember the perfect cubes, right? 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, and so on, right? I'll do one more, 64. So these are the perfect cubes. Well, what comes after 4? Well, 5, 6, 7, but then 8. So we want this to be the cube root of 8, right? That's our goal. So 4 times what is 8? Well, 8 divided by 4 is 2. So we multiply by the cube root of 2. See, not the cube root of 4, because that passes the 8. That makes it bigger than 8. We just wanted another cube root of 2 here. So multiply top and bottom by just the cube root of 2. And so the denominator will be the cube root of 8, right, which is just 2. The numerator will be 6 times the cube root of 2. And that's as simple as it gets. 6 times the cube root of 2. All right, so I think we're good. Oh, actually, 6 divided by 2. 6 divided by 2 is 3. So in the end, this is just 3 times the cube root of 2. Okay. Yeah, the original question was 6 divided by the cube root of 4. And when you rationalize the denominator, you get 3 times the cube root of 2. Again, divided by 1, but we don't need to write over 1 here. So I hope that helps. Okay, going on to the next one. We want to rationalize the denominator. 22 divided by 9 minus the square root of 5. Okay, so we're back to square roots again. Like I say, we're not going to do cube roots all that much here. So this is a square root situation. 22 divided by 9 minus the square root of 5. Now notice that in the denominator, the 9 does not have a square root with it. It's just 9. It's not the right. It's not the square root of 9, right? So it's not 3. So this makes this one a little bit trickier because there's only one term in the denominator with a square root. So, right, so there's a lot of things that can go wrong here. Your first, right, probably the first thing you would think of is, well, let's try the same thing. Let's multiply by square root of 5 over square root of 5. Unfortunately, that doesn't work, okay? And I'll show you why it doesn't work. But again, this is not the thing to do here. Because, what happens here is the following. The numerator's fine, 22 square root of 5. The denominator becomes, well, remember, there's parentheses here, so you have to distribute the square root of 5. So 9 square root of 5, I'm going to make that 5 look a little bit better here, minus 5 times 5 is 25, right? So square root of 25 becomes 5. So you have, 22 square root of 5 in the numerator, and then you have 9 square root of 5, 9 square root of 5 minus 5. Well, great, but the whole point, remember, is to get rid of the square root in the denominator, right? This is not simplified because you're not allowed to have a square root in the denominator. And notice, we still have the square root in the denominator. We didn't get rid of it. All we did was kind of move it to the other term. Okay, so unfortunately, that did not work, right? So the next thing you might try is the following. You might say to yourself, well, look, of course that didn't work because remember earlier you said you have to multiply by the same denominator, right? If we have square root of 8, you multiply by the square root of 8. Well, yeah, let me show you that again. I'm sorry to go too fast here, right? So in the second problem here, we had square root of 8 in the denominator, and we just multiplied by another square root of 8, right? So we multiplied by the denominator, the same denominator, right? So you might argue that, well, of course, now what I have to do is multiply by the same denominator, the denominator being 9 minus the square root of 5, right? Not just the square root of 5, but the whole thing. Okay. So that's also a pretty good guess, right? Unfortunately, this doesn't work either, right? And I can show you quickly why it doesn't work, right? When you FOIL the denominator, you get 9 times 9 is 81, so no problem there. Then you get the outside is minus 9 square root of 5, and then you get the inside is minus 9 square root of 5, right? And then you get positive square root of 25, right? Because that's the last terms. 5 times 5 is 25, right? So, yep, you get 81 plus 5. But then these terms, well, these don't cancel because they're both negative. You get minus 18 square root of 5. So your denominator will be 86 minus 18 square root of 5. And, right, I don't care what the numerator is because, remember, you can't have a square root in the denominator, and we still did not get rid of this square root in the denominator. So, again, a good guess, but one that just did not work here either. Okay. Yep. It seems like anything we do, we just can't get rid of this pesky square root, right? This square root here is not allowed in the denominator. Okay, so let's just show you what does work, right? What does work here is the following. Let me scroll down. Oh, I'm running out of space. Okay, so let me just write this over here. So this was the original question, 22 divided by 9 minus the square root of 5. Right, so what are we multiplying by? What's multiplying top and bottom by what here? Right? Well, if you remember earlier, or I think in the previous video, we had a situation where these terms here on the right, these did end up canceling. When did they cancel? Well, they canceled when one of them was a positive, right? If we have a positive times plus a negative, positive plus a negative, they would cancel out. They would add to 0. Right? But that's not what happened here, right? We had a negative and another negative here, right? Because these are both negative. Right? So there's an easy fix to that. Change them both to positive. Or, I'm sorry, change the second one to a positive. Leave this as a negative, right? Right, so that's the trick. That's what's going to work here. You don't multiply by the same denominator. You multiply by this denominator. And so you don't say opposite, right? It's not the opposite. If it was the opposite, you would have a negative 9 instead of a positive 9, right? So we call this the conjugate, right? So let me write that. The conjugate, let me spell that out a little bit better here. Okay. Conjugate, right? So the conjugate of something like a minus b is just a plus b, right? You change the second sign. The conjugate of a plus b is a minus b, right? So you don't change the first sign, you just change the second sign. Okay. So that's what's going to work here. So, so now we can multiply this out, and you can see I'm completely out of space, so give me a second and I will start all over here. Give me 1 second. Okay, so here was the problem that we were working on, and 22 over 9 minus the square root of 5. So we still have 22 over 9 minus the square root of 5. So, short of it is this. All you have to do is multiply the denominator by the conjugate, 9 plus the square root of 5. But then do the same thing for the numerator, 9 plus the square root of 5. That's a 5, right? Okay, so now if we do that, sorry, I'm just copying it down here. Give me 1 more second. There we go, right? Now we can do this, right? So we FOIL the denominator. 9 times 9 is 81, right? Now for the outside, we have 9 times the square root of 5. It's positive. But for the inside, we have a negative times a positive, so that's negative 9 square root of 5. And then we have a negative times a positive, so that's negative square root of 5 times 5 is 25, right? Now, you might think for the numerator we should distribute the 22 here. And you can do that, but I would hold off on that until later. I think you'll see why, right? So, so the next thing we do is simplify the denominator. All right, and notice that finally we get these to add up to 0, right? 9 squared of 5 minus 9 squared of 5 is effectively 0, and that cancels the square root, right? That got rid of the square root. So, right, so what does that mean? We have 81 minus the square root of 25, but the square root of 25 is 5. I'm going to have to scroll down a little more, right? So 22 times 9 plus the square root of 5 over 81 minus 5. And 81 minus 5, 76, right? Right. So notice, oh gosh, I just keep scrolling down. I should have gone left to right, but that's fine, right? So notice that the 22 and the 76 both contain a factor of 2, right? So 22 is 2 times 11, and 76 is 2 times, I want to say 38. Yep, 2 times 38 is 76. So we can cancel the 2's. 2 divided by 2 is 1. And so we have our final answer, 11 times 9 plus the square root of 5. Sorry, that's a 5. Divided by 38, right? And yep, nothing else cancels here, right? You can't cancel from inside the parentheses, right? Right. So I'm perfectly fine with this. Of course, you could distribute the 11 here, right? You could write this as 99 plus 11 times the square root of 5, all divided by 38. Doesn't matter to me. I tend to leave it in factored form, but you're welcome to multiply it out as well. Okay, so I hope that helps. Yep, so when you do have two terms in the denominator with only one of them having a square root, then you have to use this trick of multiplying by the conjugate, right? Not the opposite, the conjugate. Okay. All right, let's do one more, because I know this is going to be a little tricky at first. Okay, so here's a good one. 28 divided by 3 plus the square root of 2. All right. Well, I'm just going to rewrite it here. Close the denominator in parentheses. So by now, I hope you know the trick. You're not multiplying by 3 plus the square root of 2, but the conjugate, 3 minus the square root of 2. And then do the same thing in the numerator. Right, again, all of this is just 1. You can cancel it. But of course, then you're back to the beginning. And remember, the whole issue here is that pesky square root in the denominator. That's not allowed. All right, so now we can FOIL the denominator, right? 3 times 3 is 9. And then we have minus 3 squared of 2, and then plus 3 squared of 2. Right, so that's going to add up to 0. Oh, let's do that later. And then the last two terms, we have a positive times a negative. 2 times 2 is 4, so square root of 4. And the numerator, well, again, you might be tempted to multiply that out, but save that for later. Save it for later. You'll see why in a second. All right, so remember, for the denominator, this just adds up to 0. And so the denominator is just 9 minus the square root of 4, the square root of 4 being 2. Okay, so yeah, I have too big of a fraction here. Okay, good. So, right, so what's there left to do? 9 minus 2, right? 9 minus 2 is 7. And what's 28 divided by 7, right? 28 divided by 7, yes, is 4, right? 4 over 1. So you just have 4 times 3 minus the square root of 2. Again, you can write over 1 if you like, but it doesn't do anything, right? It's like 4 divided by 1 is just 4. So you don't need the over 1. And that's it. There's nothing else to do here. right? Because the 3 doesn't have a square root, right? Even if it did, it's not, right? You can't do 3 minus 2. It's just not going to work. So feel free to leave it like this, or if you multiply it out, you get 4 times 3 is 12 minus 4 times the square root of 2. So I'm not picky. I will accept either of these. Well, we already know that Connect Math might have an issue with one of them, right? It might, and I don't actually even know which way Connect Math wants the answer, because sometimes it's not clear. Just realize I will go through each and every question and make sure that, you know, if the Connect Math marks it wrong because you left it like, or let's say you multiplied it out like this, and Connect Math wants this as the answer. Obviously, it shouldn't do that. It should accept both. It really should. But we know it doesn't always do that. I will go through, of course, and check each one. And if you get it right, I will give you the full point. Okay? All right, last one, right? At least for this section. We want to simplify or rationalize the denominator, 2 plus the square root of 5 over square root of 3 plus the square root of 5, right? And again, this is about as bad as it's going to get, right? So this one is not particularly nice, but it's done the exact same way as the previous problems, right? So the problem here is that this denominator, right, both terms have a square root, right? This is the square root of 3 plus the square root of 5. Well, we do the same trick, right? We multiply by not the same denominator, but the conjugate of the denominator. What's the conjugate of the square root of 3 plus the square root of 5? Square root of 3 minus the square root of 5. So multiply the numerator by the same thing. Right, notice we're not doing the conjugate of the numerator. We're not doing 2 minus the square root of 5. It's always the denominator, right? It was in the previous problem, right? We only take the conjugate of the denominator. Okay? All right, so now we have to FOIL the denominator. So we get square root of 3 times square root of 3 is the square root of 9. And then we get minus the square root of 3 times 5 is 15. Plus the square root of 5 times 3, well, that's also 15. Right? And then positive times negative is negative. Square root of 5 times 5 is 25. Right? And you can see this was successful. This was good because we cancel the square root of 15 minus square root of 15. That adds up to 0. Right? Now you notice I didn't do the numerator yet. Unfortunately, we are going to have to FOIL the numerator here as well. So we might as well do that now. 2 square root of 3 for the first. The outside is negative 2 square root of 5. And then the inside is square root of 5 times square root of 3. That's the square root of 15. And then the last two terms, positive times negative, negative square root of 25, right? So yeah, you can see what happens here is not as pleasant because essentially nothing cancels here, I don't think. So let's do the denominator first, right? Square root of 9 is 3, right? We know this is 0. Minus square root of 25 is 5. So what do we do with the numerator? Well, there's really not much we can do here. 2 square root of 3 minus 2 square root of 5 plus the square root of 15. Now, square root of 25, we can change that to 5, so minus 5. And that's pretty much it. In the denominator, we have 3 minus 5, which is negative 2. So I'll bring the negative in front. But everything else in the numerator, these are all not unlike radicals, right? Sorry, plus 15 minus 5. So no like radicals here, which means this is the best we can do. Sorry about that. So that's our final answer here. If you leave the negative 2 downstairs, again, I'm not picky about that, but you really should bring the negative in front. Right. All I'm saying here is, if you have something like 7 divided by negative 4, I would write that as a negative fraction, negative 7 over 4. Right. So same thing here. The negative 2 is in the denominator, but you can always bring it in front, just like you can here. Make sense? Yeah, and of course you could distribute the negative in the numerator, but let's not get into that. I'll leave it as it is. In fact, this is the way I would hope the Connect Math would accept the answer. So, like I say, this is about as bad as it's going to get. The trick is to multiply by the conjugate of the denominator. In other words, you change this from a plus to a minus. If it was a minus, you would change it to a plus, right? So the conjugate, right, of a plus b, right, the conjugate of that is a minus b. And if you have the conjugate, if you have a minus b, then the conjugate of that is, a plus b. So just switch the second sign. All right, so that's it for 10.6. Yep, 10.6.